Ever wondered how long a simple relay can stay on? I mean, we see them everywhere, in cars, appliances, industrial control systems, clicking away, switching circuits. But is there a limit to how long they can continuously operate? Is it a matter of seconds, minutes, hours, or even years? That's exactly what we're diving into today. Relays are essentially electrically operated switches. A small current applied to the relay's coil creates a magnetic field, which pulls a contact, or contacts, to either close or open a circuit. This allows a small control signal to switch a much larger, more powerful circuit. Think of it like a tiny gatekeeper controlling a massive floodgate. Now, the question of how long a relay can stay on isn't as simple as it might seem. There are several factors at play that influence a relay's on-time or duty cycle. It's not a one-size-fits-all answer. We need to consider the type of relay, the load it's switching, the environment it's operating in, and even how it's mounted. Let's start with the basics. Relays come in various types. Electromechanical relays, the most common type, rely on physical movement of parts. These are the ones you hear clicking. Solid-state relays, on the other hand, use semiconductors to switch circuits, meaning they have no moving parts. This makes a big difference in their longevity. Electromechanical relays, due to their moving parts, are subject to mechanical wear and tear. Every time the relay switches, the contacts rub against each other, and the spring that returns the contacts to their original position experiences stress. Over time, this wear can lead to contact degradation, spring fatigue, and ultimately, failure. The number of switching cycles a relay can perform before failure is called its mechanical life, usually measured in millions of operations. But continuous operation, where the relay stays on for extended periods, presents a different challenge. Here, the main concern is heat. The coil that generates the magnetic field consumes power, and this power is dissipated as heat. The amount of heat generated depends on the coil's resistance and the current flowing through it. If the heat isn't dissipated effectively, the relay's internal temperature can rise, potentially damaging the coil insulation and other components. The load the relay switches also plays a significant role. Switching a high current load generates more heat at the contacts due to arcing. Arcing occurs when the contacts separate or come together, and it's more pronounced with inductive loads like motors. This arcing can erode the contacts and shorten the relay's lifespan. Environmental factors are also crucial. High temperatures, humidity, and the presence of corrosive gases can accelerate the wear and tear of relay components. Relays used in harsh environments need to be specifically designed to withstand these conditions. For example, sealed relays are often used in environments where dust, moisture, or explosive gases are present. Another factor to consider is the relay's duty cycle. The duty cycle is the percentage of time the relay is energized compared to the total cycle time. A relay with a 100% duty cycle is continuously energized. A lower duty cycle allows the relay to cool down during the off periods, extending its life. So, how long can a relay stay on? For a continuously energized electromechanical relay, the limiting factor is often the heat generated by the coil. This heat can cause the coil insulation to break down, leading to a short circuit and failure. The maximum on time depends heavily on the relay's design, the coil voltage, the ambient temperature, and the way the relay is mounted. Proper heat sinking can help dissipate heat and extend the relay's life. Solid-state relays, with no moving parts, are less susceptible to mechanical wear. They are generally more reliable for continuous operation. However, they are still affected by heat, particularly the heat generated by the switching transistors. The maximum current and voltage they can handle are limited by their ability to dissipate this heat. Solid-state relays also have a finite life, but their lifespan is typically much longer than that of electromechanical relays. In practice, relay manufacturers provide specifications for their products, including the maximum coil temperature, the contact rating, and the expected mechanical and electrical life. These specifications should be carefully considered when selecting a relay for a specific application. It's always a good idea to choose a relay with a sufficient safety margin to ensure reliable operation. Choosing the right relay for the job is essential. If you need a relay for continuous operation, consider a solid-state relay or an electromechanical relay specifically designed for continuous duty. Make sure the relay's coil voltage and current are compatible with your control circuit and that its contact rating is adequate for the load you're switching. Also, consider the environmental conditions and choose a relay that can withstand them. Remember, relays are crucial components in many systems, and their failure can have serious consequences. By understanding the factors that affect their lifespan and choosing the right relay for the job, you can ensure reliable and long-lasting operation. With that said, thanks for watching, and until next time.